right, so what we're going to do now is 27 from 5-2, and then we're going to find the local extrema, the intervals where the function is increasing, and the decreasing interval. So f of x is equal to x cubed minus 2x minus 2 cosine x. And we need to take the derivative, right? What's the derivative?
3x squared minus 2 plus 2 sine.
3x squared minus 2 plus 2 sine x, right? Now, there's no way you guys have the skills to take the derivative and set that one equal to 0 by hand. You need a calculator for this. Okay? So you're going to have to help me with that.
X equals -1.
Oh, did you find that already? Go ahead, find yours. X equals, I'm sorry, negative what?
-1.126. And x equals 0.559.
Okay, so I'm going to do a sign chart for this. And, whoops, it would help if I put them in the right order. All right, so I'm going to put in a very large number on the left-hand side here, like -10. What happens if I plug in -10 and I square it? This is going to be 300 here. So it's positive. Do you agree?
Yep.
What happens when I plug in 0? You get 0 minus 2, and the sign of 0 is 0. So this is negative. And so let's put in a large number to the right. Let's say we put in 10. It's positive again, right? All right, so we have to determine for what I can say f is increasing over what intervals?
Over negative infinity to 1.126
and 0.559 to infinity. Since, how did we know?
Since it goes from
Since it or
since f prime
is greater than 0. That's all you have to say. And then f is decreasing
from -1.126 to 0.559.
since
F prime of x is less than 0.
and then did they ask us for extreme values?
Yeah.
Yes. Okay, so we need extreme values. So let's do the slope analysis, first derivative test. We can say we got a positive slope to a 0 slope to a negative slope. So this is a max. And so then we have a negative slope to a 0 slope to a positive slope, which is a min. So we can say now that f has a, did we start with a min first? Max. A relative, I'm going to say relative here.
Do we just always say relative?
Yes, unless it's asked for absolutes.
Okay.
A relative max at x equals, the -1.126. Since, how did we know? F prime of x goes greater than 0 to f prime of x less than 0 when x equals -1.126. F has a relative min at x equals 0.559. Since, how did we know?
Since goes f prime of x is less than 0, it goes positive. Or greater than 0.
That's right.
Not less than 0.
When x equals 0.559. Okay, and we got increasing, decreasing, and the extrema. Now, if I wanted to know what the actual values are, what would you do? You would say the max would be f of -1.126, right? And you would say f of 0.559. And that would give you the actual, these would be the maxes, right, and the mins.
Okay.
No, you know, I might just to. It says find the extrema, so that yeah, I would give it as a point. All right. Do you have that in y equals? If you have it in y equals, then we can do y1 of negative 1.126 right now if you want to do that. Are you in degrees or reds?
I was originally in degrees, so I had gotten it wrong.
Oh.
But
Did you get a number for me, Marianne?
no. Now mine's frozen. You can press it.
All right, so what did you get here for f of negative 1.126?
Negative 0.0362.
0.03. All right, what about for f of, you just copy that line down and then put 0.559 in there.
Negative 2.6389.
2.63.
89.
Okay. All right. So there you go. So how easy is that to do?
Yeah, that, and I got the wrong answer at first place.
Well, but so put it in y1 and then just go to the home screen and do y1 of whatever number you want. And I usually put the position function in y1, the velocity in y2, and the acceleration in y3, so I can, yeah, I can have it all there. All right, here we go. Moving right along. Number 43. On the moon, the acceleration due to gravity is 1.6 meters per second squared. If a rock is dropped into a crevice, how fast will it be going before it hits the bottom? 30 seconds later. Fast is the speed, right? So I need a velocity equation, yes? Well, or a position, right? Velocity is going to equal, am I giving it any velocity if I just drop it? The initial velocity is what? 0. And the acceleration due to gravity do you guys remember these equations? Let me write them out. Well, but then what would the velocity equation be? T plus v original, right? And then the acceleration equation would just be g, right? So we want to know if a rock is dropped, how fast will it be going just before it hits the bottom 30 seconds later? So did you take, for part A, we have 30 seconds, and you went 1.6 meters per second squared times 30? And what do you get? Because that's the constant acceleration, right? Times the time will give you the velocity. Okay, so part B, how far below the point of release is the bottom of the crevice? So all right, so let's go back in time a little bit here. And I want you to notice that the position function, if you use our formula here, is 1/2 gt squared plus the original velocity times time plus the original position. And we don't know what the original position is. So our free fall equation on the moon is going to look like this. It's going to be S of t equals 0.8, which is half of 1.6, t squared, and I have no original velocity because I'm just dropping it. I'm not giving it any added velocity. So the original is 0, and then I don't know what its original position is because I don't know how tall the crevice is. Okay? So part A says if a rock is dropped into a crevice, how fast will it be going just before it hits the bottom 30 seconds later? So that's why you want V of 30 here for part A. Do you see that? V of 30 is equal to 1.6 times 30. Does that make sense to everybody now? That's the equation you've got to use, which is 48 meters per second. All right, so part B says, how far below the point of release is the bottom of the crevice? Okay, well, we know it takes 30 seconds to get to the bottom, right? So can we say, it's original, do you want to call the original? We'll say 0 is the ground. So we'll say 0 equals, this is for part B, what was our equation for position? 0.8 t squared plus the original position. But I know t is 30 seconds when it's on the ground, right?
Right.
So what happens here? I'm going to put a 30 squared, which is 900. So this 0 equals 0.8 times 900, which is that 720? So yes, original is equal to negative 720. Well, think about this. This is the moon crevice. Somebody's standing up here. They're throwing something down. We're not throwing, you're just dropping it, right? So what's our frame of reference? They're saying if this is 0, this is 720 above. I would rather make this negative. Are you guys okay with that?
Yes.
Making this negative, and this negative, and this negative?
Yeah, because it's going down.
Yes, it's going down. So this is negative, and so this is negative, which makes this positive. I'm much happier. So it's going to be 720 feet down, right? Or meters, I should say, meters down. Everybody get that? And part C says, if instead of being released from rest, the rock is thrown. Now somebody's now going to throw it into the crevice from the same point with a downward velocity of 4 meters per second. What's the only thing that's changing? The initial velocity is now negative 4, right? So we're going to say our new position function is S of t is equal to negative 0.8 t squared minus 4 t plus, what's my original position? 720 feet down, right? Now they want to know, when will it hit the bottom? And how fast it's going to be going. Well, when it hits the bottom, it's at what? 0. So you guys are going to have to get your calculators ready to tell me what the two zeros are for this quadratic. All right, they were so quick and got. What did you get, Megan?
Negative 32.6.
I need 3 decimals.
0.603.
Okay, and
27.604.
all right, so we're going to choose the positive one because we're not going to talk about the time we were 32 seconds before. Okay, so that's the time it hits the ground. I want to know its speed, which is the absolute value of velocity. I want that 27.604. So what's my velocity equation? It's the derivative of this, which would be negative 1.6 t, which is 27.604 minus 4, right? Because if I take the derivative of that, I'm going to get a minus 4. All right, so I can't do that in my head. what'd you get?
With the minus 4? Yeah.
48?
No, I got 40.166 without.
This number was negative 44. This one here?
No, that was positive 44.
Okay, positive.
Oh, I didn't. Don't call him. You call him negative.
Negative 48.166.
No, it's negative, but we're taking the absolute value of it, which is,
48.167.
and this is meters per second, okay? All right, moving right along. Writing to learn. Number 45, the function f of x equals x when x is between 0 and 1, and 0 when x is 1, is 0 at x equals 0 and 1. Okay, so I have to draw a picture of this. This is a, when x is 0, the function is 0, and at x equals 1, I have a 0. And then it's a line, so this is going to go to 1. It looks like this, I think, right? It's y equals x. Between 0 and 1, but when it gets to 1, it's open on that end, and then it's got, when x is 1, it's a 0, right? Its derivative is equal to 1 at every point between 0 and 1, so f prime is never 0 between 0 and 1. Do you agree with that? Between 0 and 1, the slope of that line is what? 1, I agree. And the graph of f has no tangent parallel to the chord from 0 to 1, 0, 0 to 1, 0. Explain why this does not contradict the mean value theorem.
What's a chord? Oh, wait, that's the.
That's the secant line. Okay, so what do you have to be not contradicting the mean value theorem? What are the two conditions? You have to be, mean value theorem, you have to be continuous over the closed interval, right? And differentiable over the open interval. Now, are we continuous over the closed interval here? No. So this says, explain why this does not contradict the mean value theorem. Well, because it's not, because f.
Because f of x isn't continuous.
Yes, since f of x is not continuous at x equals 1, the mean value theorem would not apply, right? Try again.
When apples.
Would not apply. Well, will not apply, okay? All right, 54. On what interval is g of x? This is g of x equals e to the x cubed minus 6x squared plus 8. And that's all elevated, okay? When is it decreasing? Well, how do I find out about increasing and decreasing?
Sine bar.
G prime, which is, this is the derivative of e in the f of x.
Oh, so it's
F prime up here. What's the derivative of that?
3.
3x squared minus 12x times e to the x cubed minus 6x squared plus 8. Now, e to the anything is never 0 and always positive. So what's the only thing that's going to change the signs here?
The first one.
The first one. So we need to find the zeros here. So this is going to be 0 when 3x squared minus 12x equals 0. Factoring out of 3x, we get x minus 4 equals 0. X equals 0 and 4. This is a quadratic. 0 and a 4. And this quadratic is opening upward, right? And so this is positive, negative, positive. And we want to know what intervals this one is. this function is decreasing from 0 to 4, right? Decreasing from 0 to 4, which now, this book will say increasing and decreasing behaviors with closed brackets. I don't like that. I would prefer open. All right, 55. Which of the following functions is the antiderivative? Okay, so that's saying I have f prime of x is equal to x to the negative 1/2. Antiderivative means what is the function I took the derivative of?
So we're trying to find f of x.
F of x, yeah, what is f of x? Well,
It was 1/2.
it was x to the 1/2, that's right, I agree with that, but
We had to break down the
I had to
then
bring
it's
down
two.
the 1/2, so it had
2x to 1.
So what happens if you put a 2 here? You get 2,
Plus c.
right, plus c, but what happens here? 1/2 times 2 is
1.
1, right? And lower the power of 1 gives you negative 1/2, so that works, right? So which one of these works? This one, right? Because that's equivalent to root x.
Trying to see if there was any
And the cupcake that they used was, they have negative 10, so that's fine. You can take the derivative of that. Now, if you didn't know, could you just take the derivative of each one of these to see if you get this?
Yep.
Yeah, that'll work too.
Too time consuming though.
Probably. Okay.
Especially on a Wednesday schedule.
5-3. We're going to use a first derivative test to determine local extreme values of functions and identify absolute extrema. So we're going to do 5. And let's see here. We get y equals x root 8 minus x squared. Does this function have a domain problem?
Yes.
It does. And this is an upside down quadratic. So 8 minus x squared has to be greater than or equal to 0. What makes this 0? Is root 8 and negative root 8? Yes?
Yep.
So if I were to do a number line, this would be negative 2 root 2 and 2 root 2. And this thing is only going to be viable between these two numbers, right?
Right.
So the domain of this function is negative 2 root 2 to 2 root 2. And the implied domain gives me a closed interval, doesn't it?
Yep. Because it can be 0.
Okay, that's right. So I have to do the product rule to get an extrema here. First, x. The second, which is
1/2.
power down, good.
8 minus x squared.
Lower the power 1.
Negative 1/2.
Times the derivative of the inside,
2. Negative 2x.
plus root 8 minus x squared, right? Times the derivative of the first, which is 1. Putting things where they belong, I can get rid of the 2's. Negative x squared over square root of 8 minus x squared plus square root of 8 minus x squared. Feels very similar to the last one that we did. This is going to be what? Root 8 minus x squared over root 8 minus x squared to get a common denominator. So we can set it equal to 0. So what happens on top? We get negative x squared plus 8 minus x squared. So it's going to be 8 minus 2x squared all over square root of 8 minus x squared. And I took a liberty here. Does this become 8 minus x squared? And 8 minus x squared, when I add it to this, is going to be 8 minus 2x squared, right?
Yep.
Setting it equal to 0. I get 0 equals 8 minus 2x squared. 2x squared equals 8. X squared equals 4. X equals plus or minus 2. When is the denominator equal to 0? At x equals plus or minus 2 root 2, right? So I'm going to do my y prime line. My closed interval, negative 2 root 2 Now those are zeros, so what are we going to do? We're going to plug in some values, or are we going to superimpose the numerator? Superimpose the numerator? Why am I not worried about the denominator of the derivative? Because it's always positive, right? So this is going to be a negative number plus numbers, negative numbers. If I do the slope, we have a negative slope to a zero slope to a positive slope, which is a min, and a positive slope to a zero slope to a negative slope, which is a max. Now they want to know about extrema, right? So what goes on our chart for absolute extrema? Negative 2 root 2, negative 2, 2, and 2 root 2. And this, I'm going to put y here, which is equal to x root 8 minus x squared. So what happens when I plug negative 2 root 2 in here? In the original function, you get? 0. Good. What about 2 root 2? 0. I just put the endpoints because I knew they were 0. Easy, right? Negative 2 you get? Negative 4. 2? Positive 4. So what wins I am the absolute max award?
2.
Absolute max? This one is the absolute min. Okay, now what did you do to go from 0 to negative 4? You went down, right? So that makes this a relative max. What did you do from 4 to get to 0? You went down, right? So this is a relative, right? Make sense? That's all there is to that one. Okay? And then they just want you to graph it on your calculator to make sure you're right. Move right along. Number 7. Use the concavity test to determine intervals on which the graph is concave up and concave down. In order to do that, to determine concavity, what do we need? Second derivative, right? So if number 7 here has y equals 4x cubed plus 21x plus 36x minus 20. 21x squared, thanks. Okay, y prime is 12x squared plus 42x plus 36. Do we have any nice factors here? 6 goes into all of them. So this is 6 times 2x squared plus 7x plus 6, right? Why am I doing that? Well, because I might need to set it equal to 0, right? So what's y double prime? This 6 goes along for the ride. 4x plus 7. So I need to do this. That means I only have one point of concavity, possibly, right? So this is 4x plus 7 equals 0. 4x equals negative 7. X equals negative 7/4. Y double prime. I'm going to put negative 7/4 on here. What is this graph? The line. The second derivative is a line with a positive slope. Good. 0, and then I know I have negative y values here, positive y values here. So y is concave up from negative 7/4 to infinity, since, how did we know? Good. Y double prime is greater than 0. Y is concave down from negative infinity to since y double prime is less than 0. Beautiful. All right, so number 9. 2x to the 1/5 plus 3. You're going to remember that, right? 2x to the 1/5 plus 3. Y equals 2x to the 1/5 plus 3. It was plus 3, right? Yes. y prime is 2/5 x to the negative 4/5. Y double prime, negative 8 over 25 x to the negative 9/5. So I'm going to put things where they belong. Negative 8 over 25 times the 5th root of x to the 9th. So when is this thing 0 or undefined?
When the denominator.
Right, so when the denominator is 0, it's 0, right? Now the numerator is always negative, right? Well, that's correct. The numerator is always negative.
Of course, Miss Muller.
Let's put in a positive number in the denominator, like 1. The 5th root of 1 to the 9th is just 1, right? So what kind of number is this? Negative. I'm going to put undefined here, so I've got negative here. And then let's just put a negative 1 in. Anything raised to the odd number is negative, and the 5th root of an odd number is negative. So this will be a negative or positive. So we can say y is concave up from negative infinity to 0 since y double prime was greater than 0. Y is concave down from 0 to infinity. How do we know?
Since y double prime is less than 0.
And y double prime is less than 0. Good. All right. Number 11. This is a piecewise. I may need some help here remembering that one. Oop. All right, so I need the second derivative here. So y prime is going to also be a piecewise. Derivative of the first part is what? 2x. The two derivative is 2. For x less than 1, what about the second piece? Negative 2x. When x is greater than 1. Now, will the slopes be equal at 1? So is this differentiable at 1? The answer is no. So I have to leave them both open. Okay, so what's y double prime here? 0, good. For x less than 1. And negative 2 for x greater than 1. So we can say y is concave down from 1 to infinity since y double prime is less than 0. What does the 0 in the second derivative mean? That means it's got no concavity, which means it's linear. It has no curvature, it's just a line, right? So, and you can say y is never concave up.
But you're saying the double of the second derivative is linear?
No, I'm saying the parent function is linear because the second derivative is 0.
Oh, that makes sense.
Because it has no curvature to it. Okay, let's see here. The next one, 13. I think that's on the next screen, right? Yes. Find all points of inflection. We have 13 here. It's y equals x e to the x. I need the second derivative, so let's find the first. X e to the x plus e to the x times 1. Now, before I took the derivative the second time, I'd factor out an e to the x, and I get x plus 1. And now I take the second derivative. So it's going to be first, the second, which is 1, plus second, which is x plus 1, the first, which is e to the x. So I'm going to factor out e to the x, and I get 1 plus x plus 1, which is x plus 2. Set it equal x over 0?
No.
No, and it's always positive. So I'm going to put a negative 2 on my y double prime line here. And if you wanted to superimpose the e to the x, you could, right? It's just floating up here. And I know that this is 0. And then x plus 2 is what shape?
1.
Linear. And so if I multiply a negative and a positive, I get negative and then positive on this side. And I was trying to find a point of concavity. So I can say y has a point of inflection at x equals negative 2 since what happened to the second derivative at negative 2? It changed
Size.
since y double prime changes signs at x equals negative 2, right? There you go. That's all you have to say. You don't have to say it went from negative to positive or positive to negative. Just tell me that it changes signs, okay? Number 21. Use the graph of the function to determine where f prime is 0, positive, and negative, okay? So f prime, this is the function. What does f prime equal 0 mean? It's a critical point, yes it is, but it's what kind of slope? 0 slope, which means it's a horizontal tangent, right? So I have a 0 f prime here and here. So I'm going to say at maybe negative 1 and 1. You follow? This is the function, and I'm saying f prime of x is 0 when x is negative 1 and 1. Everybody agree with that? All right, so I want to know when f prime of x is greater than 0. That's when I have positive tangent line slopes. Where's that happening? From negative infinity to? Good. So negative infinity to negative 1. Where else? 1 to infinity. Good. Where's f prime of x less than 0?
Negative 1.
Yes. That's, you follow that? All right. Then we want to know where f double prime is equal to 0. F double prime is going to be equal to 0 at a point of inflection where it changes from concave up to concave down, or vice versa. Do you see where that might be? This is concave down until right about here. Right, so this is at x equals 0. These are all for this function up here, okay? And then f double prime of x is greater than 0. That means it's concave up from 0 to infinity. Good. F double prime of x is less than 0, which means it's concave down from, yeah. You follow that? You're just looking at the graph and making conjectures. All right, so that's for 21. Number 22. F prime of x equals 0, right? That's when we're going to have horizontal tangents. Everybody, not all at once. Quickly. X equals negative 1, 0, and 1. All right, f prime of x is greater than 0. Positive slopes or increasing?
1 to 0 and 1. Or negative 1 to 0.
Good. Negative 1 to 0 and
1.
1 to infinity. I like it. F double prime is less than 0. That means my function has got negative slopes to it or is decreasing.
Negative infinity.
Negative 1, good.
And 0 to 1.
0 to 1. Nice. All right, f double prime of x equals 0. Now, this might be harder to see. That's that's when I'm going from concave up to concave. Now I'm concave up here until I get to maybe right about here.
Oh man.
So can we say half? Like a half?
Yeah, that sounds easiest.
And then we're concave down until we get to another half over here. Do you see that? And then we're at concave up again. So it's going to be 0 at x equals 1/2 and -1/2. Now that's just a conjecture, right? I mean, it could be something else, but I'm just saying 1/2 to be reasonable. F double prime of x is greater than 0. That means I'm concave up. From -infinity to?
0.
No.
Oh, to 1.
Yeah, -infinity to -1/2. And then
1/2 to
infinity. Good. And then I'm concave down where the second derivative is negative.
-1/2 to -1/2.
-1/2 to 1/2, yes. Okay? I didn't do 23 or 24. They're giving you the derivative and they're going to ask you the same thing. I think you guys can do that now after you watch me do this.
Yeah.
I think you'll be able to do that. All right, 36. I want to use the second derivative test to find the local extrema. Now the second derivative test, how help me spell on this lovely day? Derivative, there we go. You have to laugh or we cry, right? If I'm a critical point, F double prime of a critical point. Now critical point means I have a 0 slope, right? And my second derivative is positive. Where's the only place I can have a 0 slope?
X equals 0.
At the bottom, right? Which means this is a relative minimum, right? If I happen to be a critical point and you plug me into the second derivative and I am concave down and have a 0 slope, where's the only place I could be? At the top, right? So that means I have a relative maximum. If F double prime of my critical point equals 0, the second derivative test fails. Okay? And then you have to go back to the first derivative test, which is no big deal. Which is what we've been doing all this time, right? The slope on the left, the slope on the right, is a max or a min. That's the first derivative test. All right, so let's find L derivative here for 36, which is y equals x e to the negative x. First, times the derivative of the second, which is negative e to the negative x, plus second, which is e to the negative x, d first, which is 1. Now, I'm going to factor out an e to the negative x, because it'll make things easier. And then I'm left with negative x plus 1, right? Negative x plus 1. Now, I'm going to take the second derivative here and use one product rule, which is nice. So we'll say first, which is e to the negative x, d second, which is negative 1, plus second, which is negative x plus 1, d first, negative e to the negative x. What are we going to factor out? E to the negative x? Or I could factor out a negative e to, well, we'll just factor out e to the negative x. And then we get negative 1, right? Now watch out for this pesky negative over here, this one right here. This has to be distributed, right? The negative. So it's going to be plus x minus 1. So this is e to the negative x, and that's x minus 2. Now, I have to find my critical points to plug into my second derivative. What is my critical point? No, critical points, remember, are from the first derivative here. So my critical point is going to be, what makes that equal to 0, the first derivative? Negative 1, no, just 1, right? if I plug x is 1, does that go to 0? So that's at x equals 1, right? And e to the negative x is never equal to 0. So we want to do second derivative test. What does that mean? Well, that means I'm going to take y double prime of 1 and see what we get. What happens when we plug in 1? We get e to the negative 1 times negative 1. 1 minus 2 is negative 1. So this is equal to negative 1 over e. What kind of number is that? That's less than 0, which means, what's going on? It's a relative max. So you can say then, y has a relative max at x equals 1, since y prime of 1 equals 0, and y double prime of 1 is less than 0. Because what is this communicating? This is communicating this is a critical point, right? And this is saying I am concave down, and thus I have to be a max, right? Make sense? I don't use the second derivative test very often. I use it mostly when I have a nice polynomial that you can take the derivative of 3 times very easily, or 2 times easily. All right, moving right along. 45. Sketch a continuous curve with the following properties. Okay, here we go. Key to what? Continuous. Y equals f of x, which also means it has to be a function. F of negative 2 is 8. There it is. It's 8. F of 0 is 4. F of 2 is 0. Okay? It says f prime of 2 equals f prime of negative 2 equals 0. That means I've got what going on there? Critical point of some sort? Yep, f 2 and negative 2. Oops. F prime is greater than 0 for absolute value of x greater than 2. So that means x is greater than 2 and x is greater or less than negative 2. So what does this mean? This means my function is doing what? Whoops, let's try that. This is increasing from negative infinity to negative 2 and from 2 to infinity. Because it's saying the derivative is positive for those. And if it's between negative 2 and 2, it is decreasing. And the second derivative says this means it's concave down, right? Concave down for x less than 0. And it says concave up for x greater than 0. Okay, so we got to put that all together. This is how I would do it. It says we're increasing, so this is positive, and negative here. Does that describe what the first derivative is saying? So we got a positive slope to 0 slope to negative slope, negative to 0 to positive. So this is a what here? Max, and this is a min. And it says it's concave up till 0. No, from 0 forward. So this is plus, and this is negative. So now I'm going to take all this information. So it's concave down, and then it's concave up on this side. And draw my graph. So I'm increasing, but concave down, right? increasing but concave down, and this is a max, right? So that told me there was a max. That's increasing and concave down, right? And then I'm decreasing and concave down until I get to 0. Here we go. Boom. And then I go concave up until I get to 2, right? And then, there it is, right there. So those are the pieces. It's craziness. 60. Show that graph of f has 0 or 2 points of inflection. So I know that y equals ax to the 4th plus bx cubed plus cx squared plus dx plus e. What is the first derivative? 4a plus d, right? Oh, the 2, you're right, okay. Y double prime. 12 ax squared plus
6bx.
say it again.
6bx.
60.
6b.
That's 3b.
It's not 36, is it? I'm looking at that saying that's 36. I'm sorry, 6b x. That's why I had a momentary, lapse of reality there. Okay, so this is a what here? Quadratic. How do we solve quadratics? How do we set up? This right here is my A, this right here is my B, and this right here is my C, isn't it? So, x equals negative 6, that's going to cause me lots of trouble. Negative 6b, right, over 24a?
Yep.
Plus or minus the square root of 36b squared. Ooh, b squared minus 4 times 12a times 2c. All over 24a. X equals negative. This is going to be negative b over 4a plus or minus. Okay, help me here. This is 24 times 4. 96. Square root of 36b squared minus 96ac all over 24a. Now, what did they say? They said a is not equal to 0.
Could you factor out something in the
What?
could you factor out something in the
Discriminant?
yeah.
What did I?
I'm saying could we or no?
What?
Take out
Yeah, we can take out a 4 for sure. Does a 9 go into 96?
No. 12.
Well, I know I have a perfect square factor here, right? This is, I can pull out a 2, right? Well, I mean, right, so then if I take a 4 out, I'm left with 9b squared minus 24ac. And this would be a 4 on the outside here, a 2 on the outside, which would make this a 12a on the bottom. Now, what does this say on part A? Show that the graph of f has 0 or 2 points of inflection. What? Okay, for this to have 2 points of inflection, this quadratic has to have 2 zeros, doesn't it?
Yep.
Okay, that means the plus and minus has to hold. For it to have 0 points of inflection, that means it has no zeros, or it bounces. Right? Because in quadradicville, we can have this situation with 2 real zeros. We can have this situation with 1 real zero, or we can have this situation with none. Right? And if this is my second derivative, I'm going to have a sign change. I'm going to do it in black. I'm going to have a sign change here and here. Do you see that? Will I have a sign change on the green one? No. Will I have a sign change on the... Yes. So that I will have 0 or 2 points of inflection. That make sense?
Yep.
Part B, write a condition. That's going to involve the discriminant. I'm going to move on. I'm not going to do something like this on the test, so can I move on?
Of course. Wait, which number are you on?
60. 5-4. You know, I've given you a good clue. Here we go. Part A you can certainly do. Inscribing a cone. Find the volume of the largest right circular cone that can be inscribed in the sphere of radius 3. So the volume of a cone is what? Pi over 3 r squared h. I have way too many variables here. Is there any way I can relate? Well, first of all, what is r in this picture? R is x, and h is what? 3 plus y? So volume would be pi over 3 x squared times 3 plus y. Now they have a hint in here. They have a right triangle. Do you see that right triangle? You could say x squared plus y squared has to equal 9. Now there's an easy way to go to solve this, or a difficult way involving square roots. You see how in this equation right here we have an x squared? Can I solve this equation right here for x squared? May I solve that for x squared? And we get x squared equals 9 minus y squared. And I can take this and substitute it in. And I get volume equals pi over 3 times 9 minus y squared times 3 plus y. I still don't want to take the derivative of this yet. So I'm going to multiply it out and get 27 and then plus 9y minus 3y squared minus y cubed. And now, is that something I'd like to take the derivative of? All right, so let's take the derivative of this. Now we're down to one variable and a nice polynomial because the constant goes along for the right. So this is going to be pi over 3 times the derivative of the inside, which is 9 minus 6y minus 3y squared. I'm going to set that equal to 0. And I'm going to factor out a 3. And what happens to the 3 and the 3, the 3 and the 1/3? They cancel, right? We get 3 minus 2y minus y squared equals 0. And yes, my friends, this factors 3 and 1 and y and y. And I need a positive or negative 2 in the middle. So this is going to be a negative on the side and a plus here. So y has to be negative 3 or 1. Concurrence? Okay, then I need to do a v prime line to find a max or a min. So I'm going to put a negative 3 here and a 1. This is what kind of parabola? Upside down, right? 0 and a 0. This is negative and a positive and a negative. We want a maximum volume, right? Well, there it is. There's the max. Now, theoretically, can I have an x value or a y value that's negative 3 in this picture?
No.
No, because then I don't have that relationship there, so that doesn't work. So we know, so it's that x equals 1. We've got a max. But they want v of 1. So that's pi over 3 times, what was our v, we said, in y-ville? 9 minus y squared times 3 plus y, right, before we took the derivative? And what happens when I put 1 in there? I should make this a y here. What happens when I plug in 1? We get pi over 3 times 8, right, times 4, which is 32 pi over, I can't write, 32 pi over 3 units cubed is the volume. Now, that's not enough to say, how do I know it's a max? Max volume of cone, since v prime went from greater than 0 to v prime less than 0 when y equals 1. Okay? So that is the volume of a cone inside a sphere problem. Moving right along, 38. Stiffness of a beam. The stiffness of a rectangular beam is proportional to its width times the cube of its depth. So the stiffness of a beam is proportional, this means proportional, to its width times the cube of its depth. Now, proportional means I've got a constant of proportionality there. I'm going to call it K. Find the dimensions of the stiffest beam that can be cut from a 12 diameter cylindrical log. Okay, so do you see a relationship right away here between W and D? That's Pythagorean in nature?
Yeah.
So you can say W squared plus D squared equals 144, right? Now, there's no easy way to go on this. We could solve for W or we could solve for D. I think I solved for W here probably, because then it involves not a third 3 halves. So W squared equals 144 minus D squared. W equals the square root of 144 minus D squared, right? So S is, I'm going to put equals to K, because K is just a constant. It's going to go along to the right anyway. W, which is this, square root of 144 minus D squared. I can't write. D squared times what? D cubed. I should be bracket happy here. And let's take the derivative. S prime is going to be K times, what rule must we use? Product. So it's going to be the square root of 144 minus D squared times derivative of the second, which is 3D squared, plus second, which is D cubed times the derivative of the first, which is power down. Function. Lower the power 1 times the derivative of the inside, which is negative 2D. Yep, I'm going to do that. I'm going to cross the 2's out. And then I'm going to put things where they belong. So in the front here, we're going to get K times, this is going to be 3D squared times the square root of 144 minus D squared. What goes in the numerator here? Plus D to the 4th? Negative D to the 4th over the square root of 144 minus D squared. Common D. I'm going to take this and multiply by this, right? So we get 3D squared times 144 minus D squared, because the square roots come off, minus D to the 4th, all over the square root of 144 minus D squared. set it equal to 0. Now I factor out a d to the, well, let's simplify it a little bit. We get 3 times 144 d squared minus 3d to the 4th, right? Minus 3d to the 4th minus d to the 4th. I'm just going to take the numerator now. Is that all right? Well, actually, I'll show you that that's what we did, right? Okay, so the numerator, what happens when I combine these two? Negative 4.
Negative 4d.
What can I factor out? I can factor out a 4d squared. 4 goes into 144. 36 times? 3 times 36. 108? 108? Oh, that miracles never cease. Do we agree with that? I think I agree with that. So that's when d equals 0 and d equals plus or minus the square root of 108. Well, 108 we just found out was 36 times root 3. I mean, 36 times 3, right? So this is equal to 6 root 3, plus or minus. You do a sign chart. 0, negative 6 root 3, 6 root 3. What happens here? This is a quartic, isn't it? On top?
Yep.
And it has a multiplicity of 2 and 0, and it opens down. So we're going to start here, bounce, and go back up again, and then go back down. So we have negative, positive, 0, 0, 0, positive, negative. So what's going on at 6 root 3? A max. Why did I ignore negative 6 root 3? Because can you have a depth that's negative?
No.
No, we don't have a log. All right. So my question was, find the dimensions. Well, if that's d, how do I find w? D equals 6 root 3. W is equal to the square root, right, of 144 minus d squared. So what's 144 minus 108? 144 minus 108.
36. 4 minus 1.
36?
Root of 6. Or plus or minus 6, but 6.
Well, W will equal 6, right? So a beam with dimensions 6 root 3 by 6, I don't know if they're inches, I think they're inches, will have maximum stiffness. Since S prime went from greater than 0 to S prime is less than 0 when D equals 6 root 3. Boom. I'm not going to do B and C because the constant of proportionality doesn't change where the maximum is, does it? No, because it just goes along for the ride, okay? Move right along. Number 40, electric current. I had to assign this because I'm an electrical engineer. And current is alternating, right? That comes out of the wall. Suppose at any time t, the current I of t is equal to 2 cosine t plus 2 sine t. what is the largest magnitude current for this circuit? So I need a max, don't I? So what is I prime? Negative 2 sine t plus cosine t. I'm going to set that equal to 0. To solve this, I'm going to move the sine t over and get 2 sine t equals 2 cosine t. I'm going to divide by cosine 2 cosine t. And why am I going to do that? Because I get what on this side? Lo and behold, I get sine over cosine, which happens to be tangent of t equals 1. When does the tangent equal 1? When alpha is pi over 4. So it's going to be pi over 4 and, well,
I mean,
5 pi over 4. Let's plug a point in. Let's plug in 0 to the derivative. This is prime. 0, the sine is 0, cosine is 1, so that's positive. What about if we plug in pi? This is still 0, and this is negative, and then this is going to be positive again. So we want a max. Where is that going to occur? Pi over 4. So I want I of pi over 4, which is equal to 2 times the cosine of pi over 4 plus 2 sine of pi over 4. What is the cosine of pi over 4? This is 2 times root 2 over 2 plus 2 times root 2 over 2, which is 2 root 2's, which is, right, because these cancel. So this is just 2 root 2 amps is the max magnitude of current. How did we know? Since I prime of t went from greater than 0 to I prime of t went to less than 0. When t equals pi over 4. Okay? That's 40. 41. No, that was 41. 45. Calculus and geometry. This is the last one. How close does the curve y equals root x come to the point 3, 2? 3 halves 0. So what am I minimizing? Distance, right? So what is the distance formula? It's the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. And in this case, I know that my points are, I should say, x minus 3 halves quantity squared plus, now y is going to be square root of x minus 0 quantity squared. So if I simplify this a bit, I get the square root of x minus 3 halves quantity squared plus, this is just the square root of x squared, which is x. Now they said that you could minimize the square of the distance and get the same answer. And that's true. But I'm going to show you that it works for not doing that. So let's do d prime. What's it going to be? Power down. Function. X minus 3 halves, quantity squared, plus x, lower the power 1 times the derivative of the inside, which is 2 times x minus 3 halves. 1, right, because the derivative of the inside is 1, plus 1. So what goes in the numerator? This, right? 2x minus 3 plus 1 over 2 root x minus 3 halves quantity squared get 2x minus 2. For those in our listening audience, I have lost the crowd.
It's not true. We're still here.
Okay, they're here, but they
You
are,
lost the weak ones.
Okay.
but they're tired. They're exasperated,
We have 2 across.
right?
Yes, that's true. What are we doing? We need a break.
I understand, but I am almost done.
It's the final countdown.
Final countdown. All right, I'm a set is equal to 0. When is it 0? When x is gloriously
1.
1. Okay, now, let's talk about the denominator, shall we?
We shall.
The denominator is always what? Positive. And if it's 0, then that means your point's on the square root of x curve, and it's not, is it?
No.
So we know that it's always positive. So this is a what type of curve on top?
Positive line.
Positive line. I meant to go through that. So this is negative and then positive. So we have a minimum what? Distance when x is
1.
1. But the question says, how close does the curve come? So I want the actual distance. So I want d of 1.
D of 1.
Whoops. D of 1 is equal to the square root of 1 minus 3 halves, quantity squared, plus 1. So this is going to be negative 1 half squared is 1/4. 1/4 plus 1 is square root of 5/4, right? Which is root 5 over 2. So the distance at 1 is a minimum distance since d prime went from less than 0 to d prime went to greater than 0 when
D equals 1.
x equals 1. Press F10, please.